So the first thing is I do feel a little bit of an imposter, so I am a computer scientist. But what I really like is working on a lot of digital humanitarian projects because they really answer the why and the what about what I'm doing. So as a computer scientist, I have a lot of tools that I can access, a lot of technology. I call myself a technologist because I like the little art aspect of the problem solving a lot of these have. I try to work on and design a lot of these particular projects, but Scott Branting, who I'll show in a second, and Lori are some of the leaders on the digital heritage aspect of this as we go through. Okay, so I'm here to talk first and foremost about the DATCH project, and DATCH is this idea that you can document and triage cultural heritage. So if you go out onto a site or a building or you want to do something for preservation, there are a lot of hand techniques that you can actually use to draw a site plan, to document these stones and do the measurements. However, what we're trying to hope for is to look at how the new technologies such as the HoloLens, the new product coming out from Apple, can turn you into a superhuman. So how can it augment the human into the loop to provide better repeatable patterns? So how can I leverage computer vision and AI and XR in this mixed reality field to help you understand, to draw these gestures, to document stones, to figure out where your pegs are for your trenches that you need to dig, and to move around into this space, into these various sites. Specifically, it's important to document this cultural heritage too when you're a novice. So the reason I can use some of this is because I'm a novice computer scientist. I don't know what goes on in the field. I learned probably more this weekend on some of the challenges you face in the field going out to these different sites. I haven't gone out to Kirkenes. The most I've gone out to is sites in Florida and from Philadelphia, but they're not as ancient as some of the sites like this. ICT here at USC, we often collaborate a lot with our military partners, and something that we want to do is you might have to put an Army private into this area to do some of the documentation because it's too dangerous when you're in a war zone to actually do some of the triaging that would occur into a site as kind of the first ones in. How can an archaeologist remote provide them the tools to say, normally we do this, normally we do that next? How can we bring an internet connection in so you're kind of zooming a friend, but also doing some of that documentation, seeing what they see, working through what they're actually doing so you can save these different types of sites. And we saw a lot of different cultural heritage sites being damaged recently in some of these war-torn areas in Syria and Afghanistan and everything going on in these particular regions. So these are my main co-PIs and PIs for this particular project. Scott Branting, who was supposed to come out here but had a conflict, is a professor of anthropology. He's an archaeologist who goes out to a lot of sites and focuses on the Kirkenes site in Turkey. Dr. Lori Walters, who some of you also have told me you know, is a computational historian focusing in public history, capturing buildings, architects, and facades, but also oral histories, and I'm a computer scientist on the project. So primarily, this is a tool to help you draw and sketch. Again, you have these traditional methods, and we're not trying to replace these digital methods. I was playing a little devil's advocate to Mark, saying I want to replace and find new things that are coming out of these digital methods. But what we're really trying to do is take these red blocks, which are usually the time-intensive ideas, and try to speed them up when you're in the field. So one thing I heard is when you go out in the field, we're going to spend 6 weeks in the field. We're going to spend 4 weeks in the field. Every minute is kind of valuable. So the more you can do and do correctly and do quickly is time saved that you can expand what you're looking at, have more time to look at bigger areas, maybe take time to do something a little deeper that you might not have actually done. So we're trying to do some of the digital drawing, which is, I have a love from working with architects a lot, of trying to provide tools to do that documentation, using OpenCV to take a picture and automatically find the edges, and then just the human comes in and maybe does some self-correction as opposed to just doing it all automatically, spatially rectifying some models, maybe putting up a past laser scan that you've taken and trying to see if anything has changed. Something Lynn showed, which I really love, was my thesis was on scruffy surfaces damaging and decaying computer graphics, how things change over time, measuring how things get weathered. So understanding if I went to the site last year and went to the site in maybe 3 years later, like you talked about in Ghana, there's a lot of change that occurred, and how do we measure that change? How can we visualize that change by putting up that old point cloud and seeing specifically what we have to redigitalize or check in the field or look at in general? So this is just an example of the user interface. that we have. So the idea is you go in the HoloLens and you bring up this first menu, and this menu has a series of tools that are along the side that let you draw freeform, draw lines, draw curves, and from there, the tools that you can build up larger structures. So if I wanted to build up a stone wall, sometimes it's a regular pattern, sometimes you want to draw more freeform. I can fill in those shapes for different colors, like I showed in the previous slide, and maybe tag information onto them to say I want to annotate that with something like I want to watch this stone for whatever particular region. And that first slide that I showed was actually me playing architect or playing archaeologist, and I was trying to tag some stones for this conquito, which is in the sugar mill in Florida, which is an older structure that we're trying to preserve. So we tried to look at it before and after a hurricane actually hit to see if there was any inflection or damage, since that pretty much got a direct hit from a hurricane a few years back, to see what we can do. From there, we're trying to use the HoloLens MRTK, which is just the mixed reality toolkit, to come up with a gesturing language. So if you try out the demo, I have a HoloLens here that you can try out. Pinch to draw, holding your fingers up, grab to manipulate, keeping your fingers down. So if I draw something and then want to move it around to scale, rotate or translate it, having a gesture language to manipulate the objects that we're going to put in. And this is all a work in progress as we try to develop and move this out. So here you can start to see some of the movies to try to draw some of the different line shapes that should start coming up. So here it's trying to draw some straight lines and then filling in that shape, similar if I wanted to fill in a stone or one of these lines in the monitors, I could try to fill that in. And the blue is going to eventually give you your manipulations so you can move stuff throughout. This is showing off something that was very important to Scott this year in Kirkenes. And I have kind of a slanted plane for those familiar with the site, because Kirkenes is on the side of a mountain. What is the GPS coordinate for the one corner of the peg grid that we want to have? What's the size of the peg grid that they're going to want to do in the field based on the site and planning, and where do they need to put in the particular pegs? And can they save that when they go back next year for any annotations? Any sites that they need to go through, rather than just go through paper, it'll say digitally go over here and give you, just like Minecraft, you're going to kind of go in that direction. And then when you're there, you can see the peg with the annotations. And each one of these can be your sight line for where you would put out your normal pegs. Again, not replacing the civil engineering, sighting it out, trying to figure out where the pegs are, but trying to do this more efficiently. Because a lot of times when you get to these sites, my understanding is you kind of spend the first 2 weeks mapping and surveying the particular location. If you could shorten that time out, it can spend more time for actually doing the documentation you're hoping to do. DATCH, we've developed, again, a series of features, and we keep adding on different features as well onto this, being able to move things, show and hide meshes, change your line weights, change your line colors, trying to make it a fun tool. So I try to test it out on my kids as well. They like playing Minecraft, so I was like trying to see if they can draw a creeper, if you're familiar with the green object that explodes inside Minecraft, because I think it's a fun artistic way to show expression. But I try to don't tell the RV, try to demo it on my 11-year-old, and if she's having fun and she's engaged and she can pick up the tools, it makes me know that, okay, the user interface is kind of working. I try to do it without as minimal prompting as I can, and I don't think we're there yet, because again, for me, going to affordance is something I can just kind of walk up and understand how to use. I'm trying to making the user interface as kind of intuitive as we can. We're not there yet, but that's sort of our strive and goal, is to give you these kind of tools to make it both fun and artistic, but also important for archaeology and architecture to preserve these different sites. Scott has had the opportunity to take this out into the field, into Turkey and Kirkenes, which is the main site that he looks at, trying it on a wide variety of different people. The HoloLens has some particular features where you can set it for different languages with the voice commands. Most of the time that works. However, we've noticed there's a difference between French Canadian and French from France. Different types of Spanish have different types of inflection. There seems to be somewhere between 16 and 20-something inflections of Spanish. Also different than what you'll speak in Madrid. So it's kind of interesting to see how and what it can pick up. So we're trying to develop some of these language interfaces for the voice commands of clear all or draw a line, and everything integrated into that as well. And this is a picture of some of the stone walls that I was talking about. Scott on the top trying to visualize some feature, and then Paige, who was one of the grad students he brought out on site to trying to do some of the documentation. And for the early experiments was draw some of it in DATCH. We had the grad student going behind doing the paper in pencil and trying to compare out this year how close they actually were. And as soon as the Turkish government clears the artifacts that they took out, I'll be able to do those scans in the coming fall semester. But that, I'm sure as you all are aware more than I am, it takes time to clear your government when you're in a site and you're bringing out even materials, even digitally. They want to look at every artifact that was created and being moved around to make sure that they approve it. And this regime is interesting. I'll just say that. So this is some sites that we're trying to work on, very similar to some of the stuff that we're doing. This is trying to use it in the art world. So here, this is an artist that Scott was showing. So he could do kind of an artistic expression. So trying to take the same thing we developed for DATCH, but making it a little broader, appealing to architects, appealing to artists, appealing to archaeologists, to give them these design and documentation tools. I feel archaeology and architecture is art with a lot of constraints. So you're trying to figure out how you're going to do your documentation, what somebody else designed, what that forming content was, and what that function of it was for somebody, and trying to reinterpret that through this documentation. So adding constraints and also removing constraints if you wanted to do it in the art world, to make my creeper or to do some kind of sculpture or design in the world itself. I've also tried to apply this a little bit into augmented reality for buildings. So this is a project that was funded for NSF, but we had a problem with COVID in the fact that this project was pretty much put onto a halt because we were going to do this large human subject study, which I'll explain in a second, but we couldn't run human subjects in there. What ended up happening was this biological science building was going under a renovation. I'm sure there's renovations here happening at USC and UCLA in the area. And the idea was the architect was in Atlanta, the engineer was on the West Coast. Nobody could get on an airplane with COVID, so how can we get them to interact and get them to understand what was happening in this environment? Because this retrofit still had to go forward. The building was failing. COVID wasn't stopping time moving forward of the building aging. So we laser scanned with a Leica 360 the interior of the building and the exterior of the building, which I'll show off in a minute. And the idea was to walk through the site inside virtual reality. So we gave them a virtual reality headset and said you could kind of walk through the site in VR, but they were walking through that LiDAR scan. The facilities worker was walking through an augmented reality. So as he did the same drawing features, he would, in architecture, they would call it redlining. They would want to redline this pipe and say, no, we don't want this here with this flume system. Biological science building has a lot of flumes to get out the air and evacuate the air very quickly, different than a normal HVAC system. How can we understand what's actually happening with that site with the same documentation tools? My other project is using, not necessarily DATCH, but trying to preserve buildings and preserve the historic elements of the buildings, was using the HoloLens to project BIM data and building information modeling data. So where the studs are behind the wall, where the pipes are behind the wall. So if I wanted to put in a new outlet or a new fixture on the line, I want to be able to cut through the wall as minimally invasive as possible to try to preserve any structures or features. So we designed a series of apparatuses that the students could go through, especially when they're novices and maybe they don't know how to use a power drill, which a lot of the kids these days don't know how to do. Walk them through, this is the actual power drill. I thought the identification of tool step was, just to throw me away, but in our paper coming up in October, it was interesting that there was a statistical difference between identifying the tools with AR, where they saw the picture and was guided to the tool, and literally finding me the screwdriver on the table was challenging. I did not expect that. Some other projects that we're working on at UCF, Lori Walters directs the ChronoPoints project. This is specifically looking at documenting the life and culture of the communities, the structures, the stories, which is the essential part here, and the artifacts. So she's done the NASA Mercury Control Center. I was joking that Lisa was trying to get me in trouble because she has her own World's Fair model in Queens that she was trying to model. So when she was saying hers was the best, I'm like, oh, I cannot speak on grounds that may incriminate me. This is a researcher at UCF, Scott French's house, the St. Augustine Lighthouse, and some spots around UCF as well. We're translating this to larger spaces. So this memory scan project, which is also funded by the NIH, is designed to look at 11 kilometers of A1A, which is on the Space Coast, to document the Space Coast's life history. And the idea that we're looking here was, this was documented with a scanner donated time by Langen Engineering, which is a mobile scan. So anytime you want to build a highway or change something on a highway, they're usually sending out these type of scanners. So it's LiDAR scanning to a factor of 10 higher to do these larger spaces so that you could get the whole environment. We're putting that environment in something called Cesium. Cesium lets you load in these large tiles for these large spaces and bring in different environments very quickly, and then run people through that environment in VR and AR. So the idea is to take the oral histories of them as they drive through this particular space. Oral histories are interesting because and again, there's a lot of historians in the room, so I don't want to get it quite wrong, but it's primarily an interview style with two people talking back and forth as a conversation. Sometimes you can use a prompt of saying, oh, here is a picture, a photograph, memorabilia of the particular site to spawn something. But doing something to look at Chicago, to look at the World's Fair, and taking them immersively through your environment, or taking them through a laser scan of the environment, provides more contextual clues. So when they say, oh, we remember this happening over there, we have context on what over there is actually, because we can see what they're looking at and what they're understanding. In addition, Lori, being a historian, every historian I notice has a particular time period they're very interested in. Hers is 1958 to 1972, mid-modern American architecture and art and everything going on. And this is the Glass Bank building. So what it looked like on a postcard, what it looked like in Unreal, and what the laser scan did before it was demolished about 4 years ago. So taking the initial laser scan, our artists were able to create a realistic model. And if I go back just a few slides, again, being a dorky computer scientist, they knocked down the building because a big glass box in Florida just does not work. It's going to put in a lot of daylighting, right? Bad idea. So is there things we can do with the facade by putting in different fritting patterns, different types of louvers, ink system, some brésilets, some different types of pattern to actually simulate the underlying light that can go on in the system, see if it could save it. Very oftentimes, if they just put up a very light fritting pattern, it would reduce the energy coming in. It would reduce the temperature of running the HVAC system. And maybe they did not have to knock it down. They could actually have preserved this through some of these architectural simulations. Lori uses the same environment to understand the oral history as they're going through this environment. Vivian, who was an administrative assistant at the time, she would sit down and interview, but she has an amazing memory. One of these older individuals who can tell you every little bolt that was in this building. So as she walks her through this, they found out very interesting artifacts from the oral history of what this building was, what it meant for the coast. It looks like kind of a lunar lander, so it was designed to evoke the space architecture of the particular area in Florida, because it's right down the street from Kennedy, so it's kind of invoking this sense of wonder and awe and manifest destiny that space is the final frontier. I saw your Star Trek badge, go Star Trek, for that as we go through. Okay, these are some acknowledgments, but what I want to hopefully do is just show a few demos real quick in my remaining couple seconds. The first is going to be one of these sites that Laurie designed. So this was one of the latest ones we did. Actually, this is just showing the Chamber of Commerce building. My postdoc just sent this to me. So this is almost like real-time stuff yesterday. This is it being viewed in Cesium. And Cesium's filling in some of the imagery, and this is the Chamber of Commerce building that we just scanned, because this is going to be knocked down in the next few weeks, so we wanted to make sure we finished its preservation in the area before it was actually knocked down. Usually we put it into something such as poetry, but you could put it in Sketchfab, since I saw a lot of people have that. And again, this was the biological science building trying to combine the LiDAR scan. And you can see the flume system up top, which was very painful to go through. I helped participate in this scan as basically carrying equipment and moving tripods around for Lori, because you had to go through each one of these flumes as you were trying to model it and trying to line it up to things that were actually happening inside the building itself. But trying to give them these visuals Because again, the simulation says 1,000 words, so people don't have to. So during COVID, I rather work on the Zoom session. I rather work interactively, so I don't spend 3 hours on a Zoom saying nothing, which I feel like a lot of Zoom sessions are these days. Though I'm being recorded, I love all Zooms. I didn't say that. Okay, and then one quick stuff, and I will have a demo for this down the line. I just lost the cord. So, switching computers, if I can actually plug a cord in. That's half the battle. Hopefully this goes. I'm hoping technology just doesn't technology here. Let's see if I turn that down. Okay, turn on the sound for that. Okay, so here's the kind of DATCH menu coming up. And then we give it some initial instructions, so you can see raise your left hand to get the initial menu. I'm just going to put up the freeform drawing tool just to kind of draw, into space and have a little fun with it. Sorry, I'm going off camera. But just trying to sort of create a silly shape, and then I'll interconnect that. I do not know what it's going to do with the fill because it's an irregular polygon, but it didn't do a bad job with the fill itself there. So that way, if this was a stone or some kind of documentation, I could fill that in, but I was just trying to make a kind of a free-form shape there. I can change the pen tool to have different types of colors, different types of line weights that are associated with it as well. And then this one, which I'm going to grab. So one thing trying to document a site is oftentimes I don't want to actually touch it, that touching the cultural heritage is bad. So this will provide, hold on if I can get back my pen. You see it put a little inch away from where I'm actually drawing, but you can see it visualized with that one line, that little yellow line that shoots out of the pencil. So that way I'm not actually going up to the site and touching itself. I'm drawing on the wall, but you can see I'm maintaining at least an inch distance. That inch is controllable based on what you want. Especially, we're trying to scale that if I was trying to design a building and trying to do it from far away. You're going to have some inaccuracy, but at least you can get a rough idea of something going on. There's features to do measurement tools to go from one area. Come back in, if I can get that tool to come up. From one area to another. This drawing plane's been a little sketchy, that's both not a pun on this case. It just all went away on my screen. I think I lost the connection. But the idea for the drawing plane would be, and I'll have it over there for the demo, was I noticed when architects, they have this great analog when they're trying to draw something, they draw something in paper and they move that paper around and they'll move the plane around, was to take that actually out into the field, was to give that idea of the drawing plane. So if I want to draw the creeper actually has a constraint, and it's actually a cube, and the cube is not trivial to actually draw, so I draw one area of the cube, I can move the drawing plane around and ensure that I'm actually drawing a precise cube or a precise, that was not flattering of a shot, idea there as I'm moving a particular object around. So this was DATCH. So just a little overview of kind of some of the tools that we're working on. Hopefully that comes back up. And had it back to slides. Went back to the beginning, of course it did. Sorry. Jumping around too much. And I'll just stop there because that, and that's still not quite what I wanted. Well, this is me inferring too much onto the control. Okay, there it is. That was just the last slide. And that's our project and some of the other projects we're working on at UCF. So.
Okay, so to comment on this project, we'll have Lynn Dodd.
Thank you, Joe. I've had an opportunity to put the HoloLens on over the past couple of days, which has been, in fact, really productive and instructive. And we have seen a lot here. So this is impressive, the range of what this lab is putting out. First of all, I can say that. And I'm going to confine most of my comments to the DATCH program, and so the HoloLens features that he was just showing us in the on-screen. That was very edgy that you did that at the end of your presentation. I'm glad it worked. To the HoloLens. But I do want to say I love the fact that you are using these virtual environments as a way to draw out from people their memories, their narratives for oral history. I think that's a really productive way to envision historical landscapes really productively now, and also in a way that can be very healing to people. Because we know that one of the key virtual interventions for post-traumatic stress recovery is to expose people to various environments, and so I think that's a fantastic use of the virtual. Also, in terms of DATCH, the HoloLens. First of all, I was not the only person who noticed the leather hat on top of that you were wearing. And I thought, I wonder if that is comfortable. Because as an archaeologist, of course, I work in areas. I actually work in Turkey. I have worked in Turkey, and one of the things that I thought about in using anything virtual out there is we typically work in the summer when it is hot, and so how field robust will these tools need to be to really scale up? And so it's great to see that you're out there, that, the PI, Scott Branting, and his, the graduate students that are working with you and with them are bringing it out into the field and trying it out, and field testing it, coming back and working on it additionally. Because that's really the gold standard. I mean, it's actually the big problem I know that Microsoft itself has been trying to solve in these past months. And that is how to create something that is robust enough, in their case, for use by the Defense Department, by the Army, by the military. But I have to say that the military has got nothing on archaeologists in terms of how robust your equipment has to be in the field. We just tend not to create explosions. At least on my projects, I can't speak for everybody else. In terms of the workflow that an archaeologist and cultural heritage documentarian really cares about, I think that this is an intervention which is important. What we certainly are trying to do in a regular, say, research excavation, or in a commercial cultural resource management kind of a project, which is really most of the archaeology that gets done around us here in the United States at least, is have a lot of documentation in a short period of time that also helps us shorten the time and distance to get that information out to the public. And so here, I think that as you're developing this, that's really intervening in that particular issue and problem in a very productive way, because you're gathering data at the edge of the trowel or at the edge of the digital pen. An expert in the field is actually the person who's creating the document that is then going to be able to be published. And it can be done in a way that ends up with kind of a pen and ink style drawing, potentially, as the drawing tools and as the facility of the researchers really advances. So from that point of view, I have huge optimism about the prospect that this might be adopted, and that it really would be understood in a way that could be seen as solving problems that we really do want to solve, and as getting us to the place that we want to get to, which is to be able to present the public with information that's often very strategically important. If you're trying to build a building, you really do care that you've got all the information from that site as quickly as possible, and then it needs to be published relatively rapidly in order for then that construction to go forward. And a lot of the work that's done around here falls into that category. theoretically, I think also, as I said, when you have an expert doing the work, and even an expert who touches the wall, because I have to break it to y'all, we all touch everything on the archaeological site. So, I'm interested to see, I think I really am encouraging this to be more developed, because I think that there is such potential for it. And what I'm thinking about is the distinction between, say, an Apple Pen and an iPad, where you can have the iPad standing, if this is the archaeological site that I've just excavated, and I'm looking at various different strata here, and I need to sketch those and capture the information because it's the important vertical record that still remains. With an iPad, I can take a picture and I can annotate that picture while I'm standing here, like this, actually kind of drawing these layers. But it occurred to me, and you showed this, that it might be possible, because you have that drawing plane out there, that it could also be possible to have up here a virtual HoloLens, a picture of this that I could then be interacting with, actually at a size that is equivalent to this archaeological site, ocean archaeological site. And so, that's another thing that I think is going to be really interesting and productive, and that is as you, as the engineer and the computer scientist, really are working closely with archaeologists that these needs, these really kind of core needs of rapid, accurate documentation that can be transformed quickly into outputs. This kind of a collaborative process, I'm jealous for Scott, that he's got you and then the other folks handy. And I want to give time for everybody else to ask questions, because I'm sure that there are questions. The other thing I wanted to comment about is with a sense of a huge jealousy, and that is the importance of placing the cultural heritage work in real places. And you showed us that kind of stick drawing that represented this massive site of Kirkenesdal. This site is, it's like the size of the USC campus. It's really huge. And every year when we go back to an archaeological site and want to reestablish the grid or reset our excavation areas, having to relocate those things by simply having an RTK. You said there's a little small, portable device you had, which is great in a place like Turkey where there's a little bit of an issue as to how fine-grained your GPS can be. That I could actually have a tool that would help me say, right, this is where I needed to put that edge of my square. Because many places we have people going along and pulling things up because the communities are looking for resources, and there are people go around this kind of, those things disappear. So that's a huge advantage.
They said sheep seem to have been more.
Also, yes, animals, shepherds. I didn't want to blame the shepherds. So, I think from a logistical point of view, those two capabilities really stand out to me. And if it is, in fact, as it becomes quicker, and you are developing these drawing facilities, I think that the prospect that those frontline responders who are out in areas of conflict, or who come in right after the hurricane or whatever, that they could have the ability to take three-dimensionally GPS located materials as perhaps in a way that might not be so susceptible to photogrammetry, that has benefit as well. And that's really kind of a question I have for you, and that is in documentation. As you've been thinking and talking about doing this AR, how have you been sort of theorizing what the differences are between the outputs that you create in, say, photogrammetric capture versus these creations that are created in 3 dimensions, as you showed us that wonderful polygon that are also GPS located?
So first, thank you for the kind comments. They're very useful and helpful. One thing I just wanted to address first was the hat, is hard to take out there or things like that. This was just an early hack, especially the HoloLens 1, which I'm wearing here. Trimble has solved part of the problem. They have actually designed a shade for the HoloLens that you can just pop in like sunglasses, which has been a ton better when you're in the outdoors in bright sunlight, where the HoloLens wasn't particularly designed for, to at least address that. In terms of your question, in terms of the documentation process, something I took from your comments was interesting was actually to go back and not just have that digital polygon, but if I had, the stones was to actually create a drawing from it, a PDF, that wouldn't be that hard because they're in vector graphics already and we're making shape files underneath. I didn't consider, I don't think Scott considered either, was to take that underlying shapefile and print it out and look at it. But what we're doing in terms of some of the comparison is I have colleagues in the psychology department that helps me run a series of human subject studies because I'm always trying to study the problem and understand what's going on. Is first, we have some sites on UCF's campus and in Florida with the Conquito Rock, which I'm visualizing here, is first look at what they're actually tagging, take some photographs, some actual measurements of it, do it by hand, do it by photogrammetry, do it by LiDAR as well, and can compare what the human's actually able to do, both on pencil and paper, what they're able to do via DATCH, what they're able to do with photogrammetry and LiDAR, and compare it in both time, accuracy, space, and other things like that. So it's a human subject study we're running. I don't have an answer for you right now. I'm hoping, by the end of probably the spring, by the time we write it up. But it's a fair question and something we're looking at the study to try to prove that. But the answer would be I usually go through a process, even when they're doing the PEG thing, to give it to a novice, to give it to an expert, use that as a manipulation with some kind of human subject study and understand what's actually going through. And what they're actually doing. Similar to, I think you were doing a little bit with your work, engaging the IRB to understand what's actually happening with your VR demo that you were showing.
And when you were talking about the photogrammetry, you said you're actually making a point cloud. Is the HoloLens making the point cloud? Is that what you're saying?
No, so two things there. So when we're just doing the comparison, like say I would take this wall, I would just measure it with 4 methods. The hand-drawn one by a traditional grad student, or Scott would do it because he's more of an expert. I would do it in DATCH, and we would have one of the grad students, again, who's more of an expert, do it and go through the documentation process. And then Laurie would come in with the LiDAR. And also some photographs to do photogrammetry. But we're just comparing that particular study of if we give them the AR tool, that doesn't automatically make them better. We want to see if it did make them better, so trying to measure that at the end with a different project. So NEH is funding the development of the tool, and we're trying to engage the NSF to look at that human subject study aspect of it to understand what's going on there. DATCH itself can bring in different models. So if you had an FBX or a point cloud model that you wanted to bring in, you can't bring in, say, your site because it's huge, but something reasonable for the memory constraints of the HoloLens, because again, it's just a smaller computer. I can't bring in maybe the entire castle, all 10 terabytes of probably your data for that particular area. But if I had an example of the table that was scanned or something that was lighter on the order of megs, it would probably be able to bring that in.
So in fact, you're kind of implementing this in your current workflow as one of a suite of tools, as well as using that as a test bed.
Correct.
That seems like a productive way to do it. I think I should leave some time for other people to ask questions.
Well, thank you, Lynn.
Thanks, Jeff.
Let's open it up.
Yeah.
Can I ask what the kind of spatial control for the HoloLens is? I mean, when you go back, do you find there's a discrepancy between something you sampled before and what you're looking at now, or how kind of overlapping is it?
So the HoloLens underneath has some of the technology for some of the second phase of the Kinect, so some of the time of flight stuff. So when you're in an interior and trying to do and find some of those SLAM features for corners or things that have changed with contrast, it does an okay job. So if I save something out and drew it on this table and came back, if it could find the table and line it up, you're good to go. Since this looks exactly the same, it might pop it over here if I started over here. So the HoloLens itself isn't particularly great. So to get around that, we tried to interface it with some GPS, specifically some RTK technology. Worked great in America, did not work great in Turkey. And I had a discussion with Mark, and he was telling me some of the challenges of they sometimes block GPS signals, they block some of the RTK signals. None of this I knew already, but understanding that, and when we go out in the field next year, trying to plan a little bit better for that. And you offered some ideas that we'll try to understand. Sometimes we have to clear that with the government first and do different things. The GPS, though, has been repeatable, at least in America on UCS campus, that I would actually take it around my entire building, which is similar to size to this library. The HoloLens would fall apart for it, but RTK is able to track that and understand that environment. So if I did like a little scavenger hunt, one of the kids wants to use it for the undergrad of place the scavenger over here, place it over there, not use QR codes to bring something up like it's pretty traditional with the HoloLens. So I go out to a new site, I scan the QR code, it tells me I'm at that location, but with the GPS it recognizes it. The HoloLens suffers from that. That's why a lot of people do that QR code information. Lisa?
I really appreciate that DATCH is so simple. And I'm wondering if you will comment a little bit about the evolution of the tool set. What did you start with? What got added based on user testing? And
Sure. So I'm a computer scientist, so I probably came up with the worst user interface possible. Having collaborators that Lori is excellent, but maybe not the best programmer out there. So I'm not trying to say that pejoratively, but she's a great tester. Scott, who's an expert on the team, knows what he wants from the field. Also is not a very good coder, great at GIS, great at archaeology, but he'll say, no, this tool feature isn't working. Or we had like 5 designs even just for the menu itself to make it better, more visible. An indoor view versus an outdoor view. So as Lynn commented, and she's actually been to Kirkenes, I believe, and more so than I, so that was very good that you had her comment. It is bright outside, so that blue would not necessarily work outside. So even Scott said immediately, took it outside saying this isn't working, what do? We need to have a better interface. There's a mode for inside and outside, so that when you're outside, you have that feature to turn into. Same kind of thing, he saw me going up to the site and start drawing on. He's like, sometimes that's good, but sometimes that's bad for the site and we have to work in a tool. That's adjustable.
the offset.
Yeah, the offset. So some people want to do it. I'm not trying to stop them. That's the default mode. But if you really want to preserve your site and we're not able to touch it for whatever particular reason, you could just grab that feature and move it around. So it's a lot of back and forth, having dev meetings where we try to get the whole team together every 2 weeks, where they're just trying it out. And I try to cast it and see where it's breaking. So I quietly stalk them or observe them. But I'm trying to see where they're struggling and take notes and have the team sort of look at and try to work on that. But it's a whole work in progress because the HoloLens is going to HoloLens to do a play of that. Mark?
Thank you for showing us. As I said, I've been sort of following this from afar for a while, and it's really exciting to see it sort of up close. I want to talk about something that Lynn said, which is that, or Lynn sort of intimated, which is that it seems to me, as a field archaeologist, that the real use case for this type of technology is taking previous legacy documentation and displaying it on site for excavators to use sort of in later seasons. And the reason is, we had this sort of original model where we have somebody, as you said, standing with a theodolite or standing with a donkey and drawing out all of their sections every day. And the real virtue of photogrammetry, or even just photos or LiDAR, was that you were able to triage your time, which is to say, you could take the model now, and then later in the evening go back and actually do the documentation and not have to spend that time in the field. And so it seems like this is actually moving back to that older model in which you actually have less time in the field, right? Because you're actually doing more of your documentation on site. And so I wonder if sort of thinking about this in the opposite way might actually give people, people like me more of what you want to give them, which is time in the field. It seems to me that this actually takes more time in the field than it offers.
Yeah, so two comments there. One thing I'll drift off of, you mentioned you take 10 students out, you're planning to for UW. Somebody brought up too is, could I sync 10 HoloLenses together and show them that past documentation? I'm just like drifting it into your particular case of, okay, these 10 students have never seen the site, but I can explain them, I can show them something on drawings, but if I just showed them that past information spatially and say, and you're pointing over there and they all see you're pointing to this particular site and this is the area that we're going to work on and here's the documentation in the past, but link it spatially so you have that embodied experience of stuff going on. I'm a big fan of that. I think I agree with you when this was initially designed, it is actually taking some more time in the field that if I had photogrammetry or if I had LiDAR and I just trace over the LiDAR later, I can do that on my bed. First doing it in the field. I'm trying to change that a little bit, so I've been trying to work with Scott where the idea now is The HoloLens will take an initial mesh and it'll take an initial photo, do that automatically with OpenCV. I'll talk to you offline if you want to know some details there. But the human then will just do some touch-ups as opposed to doing the whole thing. So I will have the drawing tool and say, okay, it didn't quite register it there because nothing works perfectly in the field. This is the one I want to switch. This is one I want to switch to try to lessen that time feature. Because I agree with you, hand drawing in the field is getting a bit antiquated with some of the modern techniques. Trying to figure out ways to make you a superhuman is something we're working towards.
Okay, and that answers my other question, which was about the line, sort of automated edge detection.
Yeah, so automated edge detection in OpenCV using some deep learning methods are pretty easy. It's just when you have a lot of shadows or you have a lot of complex geometry, like the Kinkito, which I'll put a better photo up from the front, is a good example of the AI is going to cry with some of this because a lot of it, what is the stone in here? We could have a whole discussion about that. Or like what actually is a face with facial detectors? Do I detect the forehead or do I not? Are some of these in lines actually a stone or where does it actually draw the line? So sometimes it's going to oversample and you might just have to come in and delete, 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 delete. So it's quicker than doing the lines or doing it on your bed, but then you can see in sight what might be a stone, look around it, explore with your body, which I really like that analogy that you made, to see that is not right.
Yeah.
So good points all around. Yes?
Yeah, actually, I think there's, and maybe the difference between the photogrammetry model and the suit doing this is the human intervention of deciding this line, this is a shadow versus this is actually a fissure. So the act of tracing this interpretation ways that photogrammetry exactly or isn't. Falsely right lines in the shadow rings. My guys have students on paper. I love the standardization that this process or this technology standardizes. So I have students draw for a patient profile to 5 different students. That is a side of some of which you're going to draw a square around the board, and they're going to connect technically from the lines. So this standardizes all 5 of those with the same, say, drawing head width and with the ability to sort of trace in space, and get much more similar, much more state-of-the-art useful ways out of that. So I like that this poses some difference or some uniformity on the different practices of reporting in the field. And then I don't know if there cares about the other, I'm going to say, I guess, color computer vision. I would love a digital one symbol. You want to see it's a soil color, so that me saying, oh, it's light brown, and somebody else in field notes saying, oh, it's light brown, which used to be large, but light brown should be very different. This is a uniform color for the whole of physical book, the dirt under it, the dirt covers.
They're very expensive.
And now they're super expensive. I would love if you're looking at this and you have that huge physically to get, say, those divide 5 choices, this divide dirt. So that could really help smart technology perception and brain saving. It's cool problem. This. The question is, can the screen actually measure of this and see what 9 million colors it portray? Maybe get the HoloLens color the same as the book with 10YR54 algorithm. But I would love to do that.
I think it's a little complicated of an answer. Can you do that? Yes. Can you do it right with the HoloLens? No. I was even just discussing with Mark over lunch, like one of my other projects is I'm really obsessed with the sky and clouds and trying to model the sky and clouds and what's going on using GOES data, and that doesn't matter. You need to know what the light source is actually doing, so when you're in the outside, what the color of light is coming in, if it's being diffused by the clouds. But you can subtract that out. We know how to do that in computer graphics. That's one of the first things I would do is, if I had to measure from a pyranometer to measure the irradiance of all the light coming in, and I could subtract that out of my photo, I would actually get a better representation in the color of the photo. There's ways to color calibrate that with Macbeth chart or something else like that, but the irradiance subtraction's a little bit better. It's a little more tedious, but it's a little probably better in the field. I've never heard of that problem, but I think I would explore kind of that approach to deconstruct the colors to make it interesting to do that, but we should talk later about that.
Just a little bit over time.
Okay, I'll stop. The last thing I'll quickly say is, again, I love problems like this. I'm not a polymath, but I do like, from the Polymathic Center, I do like working on fun problems, and I do like talking with a lot of different disciplines, so if you ever have something, just reach out. I can be your computer scientist on call or something. Thank you.